works. Okay, we're rolling. Alright, so there's a bunch of different types of real numbers. In fact, there's 4 different types of real numbers that we're going to talk about today. So the first blank you'll fill in as real numbers. The first type of real number that's in your notes is rational numbers. And rational numbers is pretty much any fraction, but also if it's in decimal form, it's just a decimal that ends or repeats. So for example, like 0.5. Notice how it stops, right? That's an example of a rational number. You can write it beside it. Because it ends. Or if you have something like this, 0.27, what does that bar mean? That it repeats. So if you have a decimal that ends or repeats, it's called a rational number. Alright, you also have irrational numbers, and that's also a different type of real number, and it is a decimal that never ends and that doesn't repeat. Can you think of one? Yes. I don't know if you cheated or not, but that's correct, pi. Because it never ends, and pi, does it repeat or have a pattern? No, it's just absolutely random. So an example of an irrational number, and these are right here, is the number pi. You can also see an irrational number, square root of 3. Any square root that is not a perfect square is going to be an irrational number. Do y'all know what perfect squares are? Give me an example. 25. Give me another one. 4, 81, 16. Those are perfect squares. Now give me examples of not perfect squares. 15. What else? 7, 3, 20. Good. So anytime you have the square root of something that's not a perfect square, like the examples y'all said, it's going to be irrational. Alright, the next 3 type of real numbers are going to be really easy. The next one is integers. And all that is it's got to be whole numbers. No fractions, no decimals. But it includes negative and positive. So if you want to write negative and positive over here to remember. So integers are just whole numbers that are negative or positive. Whole numbers are just like it sounds. They are whole numbers, no decimals, no fractions. But the only difference is these start with 0 and go from 0 up. So if you want to write 0 up. So for example, like -2, -1, -3 cannot be a whole number. Starts at 0, and anything higher than 0, that's a whole number. Naturals are the exact same thing as whole numbers. They only start with 1 and up. So the only difference is 0 is not a natural number. Alright. So easy way to remember these 3. They kind of go together. No fractions or decimals. No fractions or decimals. Alright, any questions so far? Sorry, I need some water. Anytime I'm teaching, guys, feel free to say anything, ask me anything, stop me anytime. Or if I'm going too fast, just say, hey, can you slow down some? Any questions so far? Alright, what I'm going to do is I'm going to write 5 different numbers down at the bottom, and I want you to write them too. And then we are going to put whatever box they apply to. So if they're real, rational, integer, whole, natural, or irrational. So write these 5 numbers down. -97, 4/7, square root of 17, square root of 16, and 0.427145092 ... All of these numbers I just listed, and every number you can think of besides imaginary ones, which, do y'all know what imaginary numbers are? Okay. Any number you can think of besides imaginary is going to be a real number. Every single number. So every single number here listed is a real number. All of them. So what we can do is, see where it says real numbers up here? In this box with the real numbers, we can go ahead and write all of these. Okay? Every number you can think of is going to be a real number. Every single one. And you don't have to write the whole long decimal. You can just write 0.42 ... Oh, sorry. Alright, can anybody tell me in their own words what a rational number is without looking at the paper?
All of them except the decimal.
Okay, why?
Because the decimal is never ending.
Good.
It doesn't have a regular pattern, it's not repeating, and all of the other ones,
Okay, very good. So a rational number is a decimal that ends or repeats. Ends or repeats, okay? So negative 97. How could I write that as a decimal? Does anybody know? You can write it under this. Negative 97.0, right? Couldn't I write that as a decimal? Does that decimal end? Yeah, it ends right here. So this is going to be a rational number. Does that make sense? Alright, 4/7. Does anybody have a calculator with them? Connor, you got yours? Type in 4 divided by 7. Tell me what it says in your calculator.
0.571428571.
Okay, so it does what? Repeats. Good. It starts over with 571 right here. So any fraction is going to be a rational number, but if you can't remember that, all you have to do is make it a decimal and say, does it end or repeat? And does it? Yes. So it's a what? Rational number. Very good. Alright, what do we think about square root of 17? What do we think about that one? Alright. Very good. So it's irrational because it's not a perfect square, but guess what? If you can't remember that, and let me see if one of these is going to work for me. If you can't remember that, just type in square root of 17 in your calculator and check this out. Does that have a pattern? Does it end? Nope, it's going to go on forever. So it's what? Irrational. Very good. So if you can't remember that, sorry, this is the irrational box. If you can't remember that non-perfect square root and non-perfect squares are irrational, then you can just type it in your calculator and see what it looks like as a decimal. What about square root of 16? Why? Good. And the square root of 16 is what? 4. Doesn't that end or repeat? Yes. So that's going to be a rational number, square root of 16. Alright, and what about my crazy decimal over here? Why? Good. Doesn't end, has no pattern, so it's going to be irrational. Alright, so how do we feel about telling if a number is rational or irrational? Feel pretty good? Okay. Now let's look at the integer, whole, natural. So what do all three of these have in common? What else? Yeah, they're rational. What else? These three. Good. No fractions, no decimals. So which ones can we automatically knock out? 4/7 is not going to be an integer, whole, or natural. What else? This one is not going to be. What else? Very good. So all of these are fractions or decimals, so they cannot be an integer, whole, or natural. Does everybody see that? Okay. So what about negative 97? Good, because integers can be what? Negative. Can whole numbers or natural numbers be negative? No. So we're done with that one. Oh, wait. No, we're good. Alright, what about square root of 16? Is it an integer?
Yes.
Yes, because the number 4, right? It can be negative or positive. Is it a whole number? Yes. What about natural? Yes. Alright, how do we feel about these? Good? Okay, because we're about to an activity. So is everybody good? Don't lie to me. Alright, so flip on the back. What I want you to do, you're going to work 1 through 8 on your own, but before that we need to go over, nobody wants to write out real, rational, whole, integer, right? The whole word. So there's letters that represent each one. So I need you to write over here. So real, you can just write the letter R. Simple enough. So instead of writing real out the whole time, just write a R. Rational is going to be the letter Q. The reason they do that is because rational numbers can be written as a quotient, like a fraction. That's why they use Q. Alright, irrational is going to be I. Easy enough. Alright, integer. We can't use I because we use that for irrational, right? So we're going to use the letter Z. Now, I draw a line through my Z's because I don't want them to look like 2's. So that's what my Z looks like. Alright, and then a whole number, just use W. Natural, just use N. We'll do number 1 together, then I'm going to let you do the rest on your own, and then we're going to do something with those, okay? So the number negative 185, is it real? Yes, all of these are going to be real. Is it rational? Yes, because how could I write it as a decimal? 0.0, which ends. Very good. Is it irrational? And can something be rational and irrational? No. So once it's rational, you don't have to worry about checking for irrational. What about an integer? Yes, because integers can be negative. What about whole? No, why? Because it's negative. Very good. And natural? No. Alright, so that's all I want you to do is write the letters that it belongs to beside the number. Go ahead and work 2 through 8 on your own. And I need somebody to remind me. I'm pausing this recording. Okay, so we've done all of these. Now we're moving on to simplifying expressions. This is exactly what we did in our bell ringer, so it shouldn't be too hard. Let's see. Let's just go over, I'll let y'all pick which 2 out of these do you want to do together? 1 and 4. Alright. So in 1, what makes something a like term? I know it's silly to talk about it, but let's talk about it. They have to have the same variable and exponent. Very good. Let's write that down. Like terms. Same variable. Same exponent. So, for example, if I had like x plus x squared, could I add those? No, because they have the same variable but not the same exponents. Everybody see that? Alright, so starting with this over here, we have 8b minus 3c plus 4b plus 9c. Which 2 can we combine? Yep, and the 4, how do we know what sign it is? Positive or negative? Because it's in front of the 4, right? So that would make what? Good. All you do is add the coefficient, and what's the coefficient? The number in front of the letter, right? 8 and 4, and you leave the variable the same. Alright, so what would negative 3c plus 9c be? Very good. Any questions about that one? We can stop there because these are not like terms. Alright, looking at number 4, I guess y'all picked that because it has fractions, right? But fractions are really easy, and I'm going to show you some tricks how to deal with them. So let me hear some ideas of how to start this problem. What do y'all think we should do? Distribute the fractions. Any other ideas?
Simplify the expression.
Alright, how do we simplify that, Sid?
Combine 5x and 6x and 8y and 2y.
We can't combine them because it has the number out front. Gotcha. So distribute this? Okay. Any other ideas besides distributing the fractions?
I usually put them into a decimal.
Okay. Okay, that's what I was thinking. Okay, because if we find a common denominator between these fractions, which would be what? 12. Let's write that over here. GCD would be 12. How could that benefit us? What do we do with that 12? Do you know? Good. We can multiply this entire thing by 12. Okay? And I'm going to write it as a fraction. 12 over 1. Now, do I have to multiply this 12 by everything in here? Like, if I'm multiplying the 12 by this, do I have to multiply it by 1/3, 5, and 8? You don't have to. It's going to be much smaller numbers if you just multiply the 12 by the leading coefficient, because isn't this going to be multiplied by them anyways? So we only have to multiply the 12 by the two fractions. Okay, and what's going to happen when we multiply 12 by 1/3?
It's going to be 4.
Good. How do you know that? Good. 12 divided by 3, right? Everybody see that? See how easy fractions are? So 12 over 1 times 1 over 3 is going to be what? 4. And we can change that 1/3 now to a 4. Leave the 5x plus 8y the same. And what are we going to get when we multiply this 12 by 1/4? 3. Very good. So plus 3, 6x minus 2y. Now we have no fractions. Yay. I will say, I'd rather you, if the problem gives you fractions, that you don't turn them into decimals and give me the answers to decimals. So if they give you a fraction to start with, I want your answer as a fraction. Does that make sense? Unless you get rid of them like this. Alright, now what? Distribute what? The 4 to what terms? That's going to make what? Very good. And then we distribute the 3 to these terms and we'll get what?
18.
Good. Everybody good with that? Sweet. Alright, what do we combine the 20x with? And we'll get what? 30 what? Okay. 30x? Okay, I thought somebody said 30. Alright, and the 32y minus 6y is going to give us what? 32y minus 6y? Good. Alright, can we do anything else? Nope. We are done. Any questions on that one? Alright, work 2 and 3 on your own. Then we're going to go over them together. 2 and 3 on your own. Anybody need more time? Alright, anybody want to be brave and tell me just their answer they got for number 2? Go Go ahead, Madison.
I got 8G minus 24K.
Alright, raise your hand if you agree. Anybody disagree or have a question? Good job. Alright, what about number 3? Anybody want to share their answer? Go ahead.
9x minus 7y minus 2.
Alright, raise your hand if you got the same thing. Alright, does anybody have a question or comment about this one? Alright, go ahead.
Oh, no, I just figured that.
Alright, anybody else get anything different? What we get?
9x minus y minus 2.
Alright, let's see why this happened, okay? So, tell me your name again, I'm so sorry. Yeah, Toby. Okay, so Toby, tell me, did you write your workout? Okay, go ahead and tell me what yours looks like.
I got rid of the parentheses.
Alright.
So it's 9x minus 3y minus 2 minus 4y.
Alright, let's stop there. Okay, so when he combined his y's, -3 and -4, you would get -7. And the same thing with the x and the 2. So what went wrong from here to here?
You have 2 negatives, it makes a positive.
Good. Just when he distributed this negative to this negative, 2 negatives make a what? So that's the only little mistake, okay? And thank you for sharing that, because I'm sure other people did that too. Or I know other people did. What now?
It would be plus y.
Yes, because -3 plus 4 would be what? 1y. Very good. Very good, guys. I throw things in here. Is that okay with everybody? If it's not, I won't throw it. I promise. So, like, if you see me about to chunk something you don't want me to throw it to, you just hold your hand up, and I won't throw it. I promise. All right, everybody good with that? All right, flip it over. We're only going to do about 2 of these, and then I'm going to let you do the rest on your own because we're kind of running out of time. All of these are the same thing. Evaluate the expression. If A is this, B is this, C is this, what are they asking you to do here? Plug in the numbers for the letters, right? So, for example, instead of 2A, we would write 2 what?
Minus 2.
How would I write 2 times -2? Good. Parentheses, plus, and now instead of B, you would write what?
3.
So that's what they're asking you to do. Anytime it says evaluate, they just want you to plug in those numbers for the letters. And then we just work it out just like we've been doing. We've got to use order of operations, though. What comes first in order of operations? Parentheses. So we have 2 parentheses, but notice that this is the only one where you can do something inside of it, right? This one, can you do anything inside the parentheses? No. It's just a number. So we're going to start with this, and 3 plus 3 is what?
6.
I say the answer a lot when I'm asking questions, so sorry. Alright, what should we do next?
The exponent.
Exponent, so this makes, very good. What should we do next? Multiply, this makes -4 plus 36, our final answer? Awesome. Alright, is there anyone on this page that you want to work together from 2 through 5? Y'all good to go?
Number 5.
Number 5. Okay. Let's look down at this one. Alright, tell me what to write.
0.8, negative 0.8 plus 6 divided by 4 times 1/5 plus 5.
Alright, what should we do first? Parentheses. Good. Sid, we would distribute if one of those had a letter. But because they don't, we can go ahead and simplify parentheses first, then multiply for order of operations. So I'm going to leave the top the same for now. What would be an easy way to add these two?
Make the 5 fraction, make it 5 over 1.
Very good. So I'm going to write it over here just as 5 over 1. How do we add fractions? What do they have to have? Good. Common denominator in this case would be? Good. So this one already has a 5 on the bottom. So do we have to change it? No. This one, if we put a 5 on the bottom, What did we have to multiply this 1 by to get this 5? So we multiply the top by 5 and get, very good. So what would that be if we added them together?
26.
Over 10?
Oh.
Good. Because you do not change the denominator when you're adding fractions, just the numerator, correct? What now? Anything? Distribute the 4. How do we distribute the 4? Tell me how that's going to work. 4 over 1. Good. And when we multiply fractions, how do we do that? Good. Straight across from the top. So what's 26 times 4? You can use a calculator. 104. And on bottom we would have 5. Very good. Almost done. What now? Very good. So negative 0.8 plus 6 is going to give us what? 5.2? Alright, so now we can change this to a decimal. Okay, because they gave us a decimal in the beginning. So we can do that. So what is 104 divided by 5? Alright, so now our final answer, we'll have to divide those two, and you should get what? Very good. Alright, we'll stop there.